Hello, and welcome back to the Rawkode Academy. I'm your host, David Flanagan, and today we are going to take a look at KWasm. KWasm is a project that wants to make it easier for you to run WebAssembly workloads on your Kubernetes clusters. So guiding us through today's session, I am joined by Christoph and Sven from Liquid Reply, who are also working on the KWasm project. Hi there, how you both doing?
Hello. Yeah, thank you for having us. Super excited to be here.
Awesome. Well, let's start with a bit of a round of introductions. Why don't you just tell me more about each of you?
Yeah, sure. So I'm going to start. My name is Christoph Vogt. I'm living in sunny Hanover in Germany. I'm a father of two beautiful daughters, and I'm doing Golang and Kubernetes for a living. I'm a managing director at Liquid Reply, a consultancy which is like focusing on Kubernetes, container orchestrators, and cloud native technology. So we try to bring this cloud native and cloud agnostic mindset to our customers. And customers usually approach us to build up their Kubernetes clusters, to migrate workloads from on-prem to the cloud, to optimize their clusters, make them secure, find performance bottlenecks, write custom controllers, custom software on top of Kubernetes. And all of a sudden we also found out that WebAssembly is also a nice target that can be run on Kubernetes, and became a research topic of Liquid Reply. This is what we talk about today. Sven.
Yeah, hi, I'm Sven Fennick, lead developer at Liquid Reply. And fortunately here we are allowed to dedicate some time for open source projects. And therefore I turned the experimental work with WASM into an open source project. And yeah, that's why we are here, to show you how easy it is to get started with WebAssembly and Kubernetes.
Awesome. No, you're going to say something there, Christoph. When you go.
How easy it became, actually, because it was quite a journey until it became easy.
Well, yeah, why don't we take a couple of minutes? Like, before KWasm, what was the process of running, and was it possible to run a WebAssembly workload on a Kubernetes cluster? Why don't you start with that?
Yeah, so basically it's KWasm is not a runtime, it's not a Kubernetes distribution, it's just an installer. So we take the awesome work of the people out there who have created integrations for WebAssembly on Kubernetes and install them on the cluster. So yes, before it was possible to install it on your cluster, but you always need to know what you're doing. So in this round, that's not a problem at all. But when you think of an Blazor developer who is using his framework, it just outputs a WebAssembly file, and now you're asking yourself, how can I run this? So for this audience, we created this installer to just have a Kubernetes cluster, put an operator on it, label your nodes, and you can theoretically start your WebAssembly applications. So what it means, we will see in a few minutes. But how it was before, short spoiler, we will see in a few minutes after when we're doing this on our own cluster.
Yeah, so let me fill the audience in on our mission and our plan for today. So when we talked about doing this, you've already said, right, it's easy. Like this, it was hard, it's now easy. And that you've done all this amazing tooling, and then we're going to see the easy mode, which is to get KWasm to get a kind cluster ready for WebAssembly workloads. And you've promised me, you've not promised, but I'm going to tell everyone you promised me that that's going to take 30 seconds, right? I'm sure it'll take maybe a little bit longer.
Wow.
No pressure, absolutely no pressure whatsoever.
Just for the audience, I said under 5 minutes. Now it's 30 seconds.
I've got faith in you. So, but of course, I mean, I spun up a bare metal cluster because that's every time I need to do something on Kubernetes, my go-to is bare metal. And I think this will give us a really valuable insights into what we actually need to do to prep a Kubernetes cluster for running WebAssembly workloads and use our, hopefully, we're going to be successful. Let's positive mindset here. We're going to get this bare metal cluster running a WebAssembly workload, or no, there's no failure. I'm not even going to accept it. We're going to do it. So I'm going to.
There's a very high chance that it's going to work, right? I mean, we tried it with a lot of clusters from a lot of cloud providers. So depending on your specific configuration, I guess, like if there's anything arcane going on your machines, then it should work as well.
Yeah, it's a traditional Ubuntu machine, KWasm cluster running containerd. Hopefully what most people are doing on the bare metal environment and not going too off the beaten track, because kubeadmin works well, containerd works well, and WebAssembly is an exciting prospect. We're going to bridge all this and smush it together, and I'm excited for that.
Cool.
Let me share my screen. So there we go. We have a kind control plane, a kind cluster, just a standard done 5 minutes ago with kind create cluster command. Nothing fancy here. Yeah, Russell, I was going to mention the hoodie and I didn't want to because I don't know how to pronounce it, if it's Ori or Ori. Maybe Christoph will tell us.
I personally pronounce it Ori. Actually, I have no clue. I should have followed closer the talk from Chris Nove from the FOSDEM. So she was talking about Ori and what it's like about. Definitely look into it. It's very, very interesting and exciting project.
Can we run WebAssembly workloads on it yet?
Not yet.
All right. And that sounds like a coming soon segue. So let's
exactly.
All right. So I have my kind cluster, super vanilla. What I'm going to do is pull up KWasm here. So you've already kind of covered this, but let's just touch it again so we kind of clarify it for the audience. KWasm is not a runtime. So maybe you can give us a TLDR and what we're about to do to our kind cluster.
So basically, there are different kinds of runtime at the moment available. One is the WASM Edge runtime, which is basically used by Docker this is powering the Docker WASM integration. And there is also the spin-based containers. At the moment, there is a WASI node pool preview on Azure. So you could already use them on Azure with the node pool preview. And we thought, why not make it available to the other clouds and even for local development? So that's basically the idea, using this existing runtimes and installing this on your cluster. On the left-hand side, you have the quick start, and that would be everything you need to get started with your kind cluster.
Okay, so looking at this, KWasm can prepare my cluster to run WASM Edge applications, WASM time applications, or even Fermion Spin applications, which is very exciting for me. I do a lot with Spin, and I'm excited to see that in my Kubernetes cluster. So looks like the installation is Helm-based.
Exactly. So we thought it is a common way to distribute some YAML, and that's why we just go with Helm.
All right, I'm just going to very quickly run through this. I am going to modify your Helm command because I don't know. I just feel very uncomfortable when I run Helm install. I always have to do upgrade -- install. I think the idempotent of it just makes me happy. So we're going to have a Helm release. It's going to be called KWasm Operator inside the KWasm namespace, and we have a chart KWasm Operator. For anyone coming from Kubernetes, this is all stuff that they're very happy and comfortable with, so no surprises. What I do want to do before we move on to annotating any nodes is just look at what we have inside of our cluster. I'm assuming it's just going to be a single pod running your KWasm controller. So.
Yeah, it's just an operator using the operator SDK. It's written in Go. So if you're familiar with that, it's just all the defaults you can use.
All right. Now, it doesn't do anything by default, I'm assuming, based on the fact that the next instruction is to annotate a node or all nodes in our cluster with KWasm.sh,
operator, so it should not do anything without you having told it so. So there are also values in the values file of the Helm charts, so you could do it in one step, but to be safe, you should install the.
Oh, we lost them.
No.
Oh, I've lost everybody. Sorry, I have no idea what happened there, but I think it was an error on eCam.
Me neither, so.
Hopefully Christoph comes back to join us. Yeah, all right. We'll carry on for now. Hopefully he makes it back. I think it was just a temporary blip, and it seems to have resolved itself now. So we were, yeah, there we go. Welcome back, Christoph. I don't know what happened. I think it's my software. I don't think it's you, because I got an error message saying eCam error, but it looks like we're okay now. So,
all right,
sweet.
Yeah.
So we're about to. We've already annotated our node. I'm assuming now you've installed some sort of eBPF rootkit onto my machine. You have root access, and you're mining on my bank details in Bitcoin. Is that correct?
To be precise, yes, this just installing something from a random Helm in the internet, starting a super privileged container which can do something on your node is as good as doing a curl and piping is with sudo in bash. So it's the same safe situation you see on all the websites.
So in fact, we cannot promise you what's happening in any case.
So, I mean, my understanding, and I'm often wrong, so feel free to correct me, right, is that we haven't really done anything to this cluster except you've provisioned some WASM runtimes onto the underlying host.
So when you see the difference to the pods before, there is now a completed job.
Yep.
So, yeah, exactly. And this job was just executing a script, so the container is running as root. In the script, you have an ns-enter, you exit your container, you just walk out there, place your binaries in the specific folders of your host system, and change the containerd config and restarting containerd. So we will see the script afterwards, but that's basically what happened. And as I said, it's like piping something from the internet into your bash. You can just do anything.
This is, by the way, also maybe to add on this, because usually what you do in case you want to do something on the host on the level of the host of multiple machines, you're using a daemon set. So we considered using a daemon set, but what we didn't like about the daemon set that even after the install process, the daemon set would still be provisioned on the node. So therefore, this highly privileged container would also still live on your node, and therefore we basically decided to start a job once the new node is starting, and to start the job and get rid of it once it's done. So this basically was the idea.
Cool.
Yeah, and now when you look at the website, we have two example workloads. So one for Spin and one for WASM Edge. So when you scroll down for the WASM Edge, this is the manifest. You create a runtime class for C1 because we are using the C1 integration here, and then starting a container, a pod with a container. The one important thing is the annotation you see here. The module WASM image variant, that's something special to C1. So C1 usually works like run C as an OCI runtime, but if you give this annotation, it looks into the container and sees is it a WebAssembly container or a Linux container, and if it's a WebAssembly container, it's executed with WASM Edge. This approach makes it possible to start pods with Linux containers and WebAssembly containers. So your WebAssembly workload is with C1 able to run in sidecar integrations like Linkerd, like KDA, or Dapper, whatever uses sidecars. So that's why we are using not the container dshim here, but the OCI runtime. We could use the other one as well, but this has still a slight advantage over the other one.
So I want to confirm something there, because I think it's something that's really exciting for me personally, and hopefully for others. But using this approach with crun and the annotations, we can have our main application, right? Say that just happens to be a Go binary right now that has a web server serving traffic to customers. Maybe it's an API, whatever. It doesn't matter, right? We can run a WebAssembly, server-side WebAssembly workload in the same pod and perform standard sidecar capabilities. Maybe that's log transformations, maybe that's metric collection, or something like that. Is that something that is possible now, or something that's possible in the future?
So basically, you can now run pods with both type of containers when you are running crun. So that's working. With a log transformation, that's slightly different because you need to access the logs.
Yeah, so if my application obviously is writing to standard out, but I could have it multiplex that and put the standard out into a file as well. Can I share that file with the WASM Edge runtime application?
Let me short think about it. Yes, if it's available in the container, you should be able to access it.
Isn't that cool? That's cool, right?
Yeah, it is. So I haven't thought that to an end because I was always doing it's the other way around. So WASM was always my main application, and I had supporting things around it. And I have never used WASM as a sidecar to support another application. But I like the idea.
Well, yeah, I guess that's bi-directional, right? I think either way, I think the point is completely valid, and that's what I want people to kind of take away from here is that, writing server-side WebAssembly is cool, and I'm hoping that the audience is somewhat sold on that, right? And if you're not, go start experimenting with Spin and WASM Edge and all these other runtimes. But it's this being able to use WebAssembly side by side with containers, which is really appealing to me personally. And I think these kind of hybrid architectures will be very big in the future. Now, let's not take your word for it, right? Should we deploy this?
If you scroll down a bit, you have the same safe approach to just put some YAML into your cluster.
I don't mind. I trust you.
Yeah, and that's running an, I would say, extremely basic job, which is putting some information from the environments, generating some random numbers, getting the environment variables. So just to show you that the WebAssembly integration is working. Maybe we should have started it before integrating the WebAssembly runtime so that you can see it fail, but now you need to trust me that's a real WASM application and not something written in Go.
Oh, don't you worry, because look at this. By the power of magic, we can go to another cluster that doesn't have KWasm installed. So let's see. I need my IP address because I've accidentally removed it from my buffer.
And we slightly hit the 30 seconds you have promised, but I think that's only because of connectivity issues.
Yeah, it's all right. I'll take the blame for that one, 100%. So this is a bare metal Kubernetes cluster running on Equinix Metal. We have a lot of cores, a lot of RAM, and we're going to run the smallest WebAssembly workload in the world. But still, it's fun, right? So
yeah,
there we go. 48 cores.
Wow.
Nice.
Just for the giggles. And what was the gig? Yeah, 64 gig of RAM. So this is standard cluster, like so. It is running my clustered workload and a Postgres app, but we can ignore that for now. That's just because I use the same automation, just because it's a lot easier for me. But I'm going to take your kubectl apply command here. Now, I guess what's important here, right, is that we will be able to define the runtime class, and we will be able to define the job, because these are standard Kubernetes objects, but it shouldn't run because it's going to try and run it with something that doesn't know how to interpret it. Is that correct?
Yeah, it's trying to find crun, and containerd should reject that with, I don't know, something like crun. And therefore, it should stay in container creating forever.
Okay.
And
so
if
we
you describe it, yeah, you will see that it's just saying about, I don't have this runtime.
There we go. Perfect.
Yeah.
So now we
Now,
need to get this working. Now,
exactly.
this might be a naive question. Are we just doing a Helm install here?
I would say we are looking at the installer, and you, who knows your cluster best, says if it would work or if it not would work.
What do you think the probability is of me doing Helm repo add Helm install and it all just working magically?
Yeah, 30%.
I thought it would have been higher. All right. Do you want me to do this with Helm or do you want to do it manually? Let me ask that.
Let's have a short look at the installer script, and then you can say if there would something be blocking the installer, and then we can try it, okay?
Yeah,
so on the right upper side, you just end in the repository of the operator. But if you go to the organization, there's also the KWasm node installer repository. And I really love demystifying things. So there is no magic. So here's a Docker file in images installer. And the Docker file is just downloading, compiling and downloading the runtimes and putting it in a folder called assets. If you go back and look at the script, there is an installer script. And it just tries to find out if it's in an environment where you just can't use the standard procedure, then it's slightly adapted. But in the end, you are just copying the binaries in some spaces, like in this case, opt KWasm. You are linking the bin files, the lib files, and then this tiny containerd config snippet is executed, where you just add to your containerd config the crun runtime and the spin runtime, and I think also the slide runtime, but I haven't it in, no, I don't think so. And yeah, after that, it's just restarting containerd. So could work on a standard Ubuntu-based containerd Kubernetes.
Yeah, I don't see anything here that has me concerned.
No.
The only thing, and I don't know how your script handles it, is I don't think there's a containerd config by default. But other than that, we should be okay. I'm assuming you just create it anyway if it doesn't exist. So let's find out. I'm curious. So I've added the repository. Let's do the install.
But this was the reason why I was asking like about the operating system beforehand, because I knew that we are restarting with a systemctl. So
yeah,
this is a standard containerd install. System D is there. I think.
Let's see.
I think everything is going to magically work, and the stream's going to be finished, but everyone's going to be super happy because it just worked.
Possible, yeah.
All right. Let's annotate our nodes and see if we get our job. Oh, we got an error.
Yeah. Luckily, we have an error.
All right.
This makes the stream more interesting. It's good. It's good.
Hey, debug is my favorite pastime. I knew it was the containerd config. So we can fix that, right? We just need to create and generate the default containerd config. So we could do that with, is it containerd config dump or is it try control? I can never remember. Yeah, the containerd config dump or default is probably what we want.
Yeah.
And then we want to write that to toml, and we'll probably need to make that directory. Look good to you?
Yeah.
Okay.
Interestingly, all of the other Kubernetes distributions always had a default container config. So
Yeah, when you apt install containerd, because it uses the default config, there's no tweaks.
yeah,
And it just works. Because as you know, I have a show called Clustered, and every time I see a containerd config, I know somebody's fucked with a containerd config. So get pods. Hey, it worked.
Yeah.
Did it? Where's the job? Oh no, it's in the KWasm namespace.
Yeah.
All right. So those are all old. So will I have to clean them up to get a new one to start? Yeah, let's just. I like to delete all approach. That's how I fix things. So.
Okay. Now you would need to go to your node, and there is the annotation we added, and there is another annotation provisioned, and we just need to remove it. So we need to edit the node.
I mean, can I just do dash on this to remove
Yeah.
it?
Yeah.
Oh no.
Yeah, maybe you can show the annotation so that we can see it actually.
Okay. Yeah, you're right.
Show. Yeah.
So you want me to remove this?
Yeah, exactly.
And search for
And there
KWasm.
is, yeah, host. Yeah, exactly. No, host name is okay. Yeah, that should be it.
Oh, there's another node, so let me just delete.
We only need to start it on one node to see if it's working, and then we could do the other one.
Oops. Okay, re-annotate it. And we should see, hopefully. Oh, we're not seeing the jobs now. Is that my fault?
Okay.
Now the real debugging starts.
Yeah.
Oh, the job already existed. We should probably have cleaned that up.
Okay, got it. So it created the job, but it didn't change, and therefore, yeah.
Okay. So we'll edit our nodes again. Search for kwasm.sh. Start deleting annotations. And then I'm going to annotate one more time.
I see we definitely need to make it more comfortable to re-provision nodes.
All right, let's see if we can work out what's going on with this. So we still got an error. Oh, did I created you? Oh, no, wait, that's on the worker node, right?
Possible.
Yeah, because I only did it on one node, but that should be... We should still see our workload scheduled, right? Perhaps. No, because it's scheduled on the worker node because of the scheduler and the tense. I love how I'm just making everything more difficult for you with my setup. But...
Yeah, okay. Interesting.
So, no, yeah, this is... Okay, let me make sure the audience understands why we're running into a problem right now.
Okay.
So KWasm failed to do the installation because there was no default container config. Now I created one on the control plane node, removed all the annotations, and we ran it again. However, our workload is scheduled on the worker node where I did not create the default container configuration, and that's why currently things are still not working. However, we can split this, and I'll jump onto the worker node too. And all we need to do, hopefully, is make dir containerd and then do containerd config default and write it to the expected location. Now, the config will exist, but we will need to re-provision the nodes, potentially, unless that job is still running.
Maybe we hit the maximum retries.
Yeah, I think that's definitely the case. So, in order to clean this up, we do need to delete the job. We do need to edit the nodes. Find the KWasm.sh.
Yeah, you only need to remove the label. Okay.
Yeah, it's just easier,
Yeah.
and then I'll just reapply it. Now, hopefully, we have 2 completed jobs. So,
Yeah, we completed, yeah.
so
Nice.
KWasm worked perfectly. The only problem was the container deconfiguration and my talking too fast and trying to debug things. However,
Yes.
this should mean we have our WebAssembly workload scheduled on the worker node. Feeling confident?
David, this means you can create one of the first bug requests in the issues of our GitHub repository. That's nice.
Look at that.
And it wasn't that job completed.
All right. Now,
Cool.
there was another example here, right?
Yeah.
Where we could run the spin application.
Exactly.
So shall we do that too?
Yeah, sure. So it's the same approach. We just create a runtime class. This time it's called wasm time spin. And then we start an, I would say, very simple example from the containerd wasm shim repository.
All right. So if we run. Now this one's running. Is it fair to say this is an HTTP application that's going to say hello world every time we curl it?
Exactly.
All right. Now, it's just a deployment, right?
It's just a deployment.
Okay, so there's no service, which means
No service.
we'll have to port forward.
Yeah.
The deployment, exactly.
Or just expose it.
I never remember the syntax for that.
No problem.
Yeah.
Port forward is fine.
Yeah, I have no chance. So,
You can do deploy.
Can you port forward to deploy?
Yeah, you can. You can do a deploy / and then the deployment name.
It resolves automatically a pod and does a port forward to a pod, but it should work.
And do you know the port number? I think it might be 3000.
80.
80.
It's just 80.
Oh. All right. So I need to get a second session on our control plane. No, worker, right? Worker. No, because I'm port forwarding from the. I'll get there.
Okay.
Localhost.
Yeah, you should get a 404, right?
Yep. So if
Exactly.
we do
So
hello.
yeah. Hello, welcome
Hey.
in. And you are on the worker node, right?
No, I'm on a control plane, but we're port forwarding from the control plane to the worker.
Okay. So interestingly, you could now see what the installer has placed. So in the on the worker node in your opt folder, there should now be a bunch of binaries and libs.
Yeah.
There is a KWasm folder. And there are the bin and lib folders, and there you find the containerd shims and the C1 binary. And the C1 binary needs the shared object from the WASM edge library, which is in the lib folder, and they are symlinked into the according folders of your operating system.
Nice. So this is pretty cool. Like, I now have a spin application running inside of my Kubernetes cluster, which I'm pretty happy with.
I think it would be worth to look into the container just to show what's actually inside of the container that we just provisioned. Because like a spin application needs at least your WASM binary and also your spin toml, like the configuration for the spin server.
So is it going to be possible for me to get a shell?
No, it's pretty much like a distroless container, so you don't have a shell in there, which also means you could do a debug like with a distroless container.
I mean, I'm going to have to read the help page for that because I have not used kube control debug very much at all. So let's copy one of these examples.
Yep.
Well, I think this one, yeah, add a debug container and exec into it.
Yeah, and with busybox.
Okay, so let's get the pod names first because we'll need that. And then this is going to do kube control debug. I guess my pod is the debug pod name, which is going to run busybox. And we want to, oh no, I think it's the other way around, right?
Yeah.
So we want to debug the spin pod.
That sounds right.
And we're going to copy it to debug spin.
There's just an S missing in the copy from the pod name.
Thank you.
Yeah, one thing I haven't thought about before is that we are now starting a Linux container in a spin pod, which is interpreted by the container D shim spin, which can't handle Linux containers. So this approach is only possible with the C1, which
Okay.
is not running a server, but a job. Okay. Yeah, things to improve.
I guess then you have to believe us for now, and but we could at least look into the Docker file so that you can see how we would create such a Docker file, because
Yeah,
sure.
So when you go into the repository of the Deis Labs guys of the container dshims.
Oh, the Deis Labs one. Okay.
Yeah, we are using the example directly from the source.
Exactly.
This repository?
Yeah, it is. And then
that's the
sources.
Yeah, and then there are images. There is the spin example, and there is the Docker file, right? So what it basically does is spinning up a build container, then doing the build of the binaries, so bytecode files. And in the end, it's just using from scratch and is copying all the files needed, which namely is the spin.toml and the two modules that are referenced in it. The spin.toml is in this folder as well, so we can have a look at it. And here you see the two components, which are just referencing to a WASM file that's in the root directory and a route where you can find it. And this is the hello route we have used. So there's also the go hello route where you should get an hello from the go module.
Nice. All right. Let's recap everything that happened here. So we had a vanilla Kubernetes cluster. We used Helm to add the KWasm repository and install the KWasm operator. That sets my cluster and does nothing. When we annotate a node or multiple nodes and say that we want to run WebAssembly workloads on it, the controller will spin up a privileged pod and throw all the binaries that we need onto the host to run our WebAssembly workloads. This then means that we can add runtime classes for whatever WebAssembly runtime we wish to run workloads on, whether that be WASM Edge or Spin or others. And then we just spin up pun not intended, standard Kubernetes deployments with an annotation that says this is smart compat, which tells it to find the correct WebAssembly workload to run the application. And by magic of everything that just happened, we can run our server-side WebAssembly applications inside of a Kubernetes cluster side by side with container workloads, even in the same pod. Is that right?
Yeah.
Absolutely.
What a wonderful world we live in.
And if you're like living on the cutting edge and you already have a working spin application, then it should already work. I mean, we have some limitations in terms of like, for instance, the Redis integration is not yet working. But apart from this, like as soon as you're not doing anything fancy, it should be working.
And if you are doing anything fancy, so we are also glad to receive issues and forward them to the right position. So it should be more and more fancy with every release.
Awesome. All right, let's pop back over to our big faces so we can kind of chalk this out. There's one question in the chat which is unrelated, but you know, I've got opinions, so I'm just going to answer it anyway. Elbed is asking, what is the most used CNI in production? Is it Cilium or Calico? I mean, I'm just going to go straight out and say, if you're not using Cilium, you're probably making a huge mistake. I'm such a huge fan of Cilium. Cloud providers are adopting and supporting Cilium. Do either of you have any opinions on CNIs before I pop the question away?
I tend to use Cilium since I first encountered it in 2019 in the KubeCon NA, and we're talking to those guys, and they're beautiful people. I had the chance to meet them in person, and very, very clever guys, and the product itself is really like a blast. And if you ever like had really a network problem and had the chance of using Hubble, their visualization tool for visualizing traffic and this kind of stuff, like ended.
Oh, yeah, sorry. Yeah, I couldn't agree more. I mean, Hubble is like a superpower, right? That L4 and L7 visibility into your applications, being able to visualize network policies. This is not a Cilium plug or whatever. I'm just a huge fan of Cilium. So yeah, I couldn't recommend that enough. Oh, we've lost Sven. Oh, we've lost. They are trying to join again, but of course my software is being a pain in the ass today. Sorry, folks. We're so close to the finish line, and my software is giving you both a hard time. So sorry about that. But thank you for coming back.
We're back again. Just one last thought about Cilium. I mean, there must be a reason that it's basically used by all the major managed services. So
yeah, I couldn't agree more. It's fantastic. All right, let's jump back to WebAssembly. We'll finish up. I want to say thank you. You've both spent a lot of time with me today as we've done a couple of activities, and it's just been fun talking to you. It's nice to meet and speak with other people that are as excited about this hybrid future world of WebAssembly and containers side by side. Something you mentioned earlier. Oh, Sven's gone. I'm hoping that doesn't mean that you're going to drop again.
Let's see.
You mentioned something earlier that I thought was interesting. We haven't mentioned on the stream, and I figured maybe we could touch on that. Like, the goal is for KWasm to not exist. Is that correct? And maybe what's going to happen in the next 3, 6, or 9 months is going to get us there.
Exactly. So, like, KWasm is there to actually not exist, to bridge. So, like, to increase the adoption of WebAssembly and to make people, to make it easy for people to try WebAssembly out and run on the Kubernetes cluster. Again, we are a Kubernetes company, so we are actually not really earning money with WebAssembly. I mean, maybe some point in the future, maybe with some consulting or in this something like this, but definitely not with KWasm. This is not the goal, and also like we will probably not create any WebAssembly product or something like this. There are way more smarter people from as I said, Fermion, Wasm Cloud, and so on. So from our perspective, we try to contribute something back to the community. Try to be on the edge to understand the developments there. I'm not sure, Sven. What do you think? He's thinking nothing, or so he's not frozen at least.
No, but the audience are saying that it's potentially my bandwidth that is the problem. And I've actually we're streaming in 4K, which was not intentional. And I think it's causing a little bit of problems. I'm not sure if Sven is still here, but you know what? This has been a lot of fun. KWasm People can go and play with it today. If you run into issues, open issues, feel free to contribute. It's all open source. Get involved. If you want to discuss WebAssembly Kubernetes in more details, reach out to Christoph or Sven. Reach out to Liquid Reply. Get some assistance. Wonderful people doing really cool work in this space. I just say thank you both for oh, he's gone. Thank you for joining me today and showing us this project, showing us how to get started with server-side WebAssembly in the Kubernetes environment. It's a really exciting time, and I can't wait to do more with it. Any last words, and I'll let you go, because it seems to be plentiful, bountiful problems today.
Yeah, just thank you for having us. As you just mentioned, if you have any kind of questions, feel free to reach out either on the repository or Sven and me. We are both also available via Mastodon and Twitter. So those are probably the best ways to approach us. And also, like, if you have any kind of like improvements or things that you would like to see, so we're happy to integrate this.
Can you hear us now, Sven?
I think he's gone again.
Yeah. Well, sometimes there's problems in streams. I'm really sorry about that, but thank you again. I'm glad we can at least still talk and finish up. So have a wonderful day. I'll speak to you all soon, and thank you all for watching.
Thank you so much. Bye.